YouTube and fellow math students and math teachers. Mrs. DeVore here, doing a brief introduction to exponent rules. By the end of the video, you guys should be able to know and use the definition of an exponent, as well as use the rules of exponents to simplify some basic expressions. Now, I'm not going to go over every single rule in detail. My goal for today is just for us to very briefly scratch the surface of what it means to work with exponents. First, a little bit of vocabulary. An exponent is just a shortcut notation for repeated multiplication. Now, what do I mean by multiplication? In the examples you see below, you see 2 to the third power. Now, we would normally write this, if we think about it, as 2 times 2 times 2. However, we quickly figured out as a species that writing all of those 2's like that is really annoying and takes a long time. In fact, the first time this notation was used was by a Greek mathematician named Euclid sometime in the 4th century BCE. So roughly 2,500 years ago, we figured out that writing out all of those 2's just took way too much time. Euclid was a pretty smart guy. This wasn't the only thing he contributed to mathematics, but in our situation, it certainly makes our lives a lot easier. Now, if we were to evaluate 2 times 2 times 2, if we put that in our calculator, we would, of course, get 8. Now, this one's going to be a little bit different. We have negative 2 to the third power. That really means negative 2 times negative 2 times negative 2. When we evaluate this, we do need to be very careful of our signs because we are now going to be flipping between positive and negative numbers. Negative 2 times negative 2, of course, gives us positive 4, but positive 4 times a negative 2 gives us negative 8. Now here's where it gets funny. This is a little quirk of some of this exponent notation. This third example is not the same as the second example. The parentheses really do make a big difference. What this actually means is negative 2 to the third power, which, as we evaluated above, is negative 2 times 2 times 2, which is negative 8. The parentheses do make a very big difference because it's the difference between taking negative 2 and multiplying it by itself 3 times, or multiplying 2 by itself 3 times and then making it negative at the end. It does make a very, very big difference, so please be careful as you're going through some of the activities, that way you don't get tripped up. Alright, we're going to go through now and talk very briefly about some of these exponent rules. The first one we're going to say is the 0 exponent rule. And all it says is that anything to the power of 0 is 1. Always, forevermore, amen. Anything to the 0 power is 1. The negative exponent rule says anything to a negative power. In this case, a to the negative n power is the same thing as 1 over a to the nth power. Or, say we have this negative exponent in the bottom of our fraction. 1 over a to the negative nth power is equal to a to the nth power. The multiplication rule, or sometimes called the product rule if you look it up on Google, says that a to the nth power times a to the nth power is a to the n plus mth power. We add our exponents. The division rule, or perhaps the quotient rule, as sometimes Google likes to call it, we take a to the nth power divided by a to the nth power equals a to the n minus m power. We subtract our exponents. The most important thing as you're going through all of these is that in order for these multiplication rules to work, the big number, the base of our exponent, has to be the same number all the way through. If it's not, we can't follow these rules. So just be very careful as you're going through these. And just make sure that before you do any of this, don't waste your time if the bases are not the same, because it won't work out like you want it to. Finally, we have what I call the distribution rule, but if you look it up on Google, it's often called the power rule. It says that we have a number a to the nth power. We're going to take that number and we're going to take it to the mth power. This means that we are going to multiply our exponents together. Another example of this is, say we have 2x to the second power. That means that we take 2 to the second power, which is 4, times x to the second power, or x squared. Very important though, if you see something like x plus 2 squared, please do not try and distribute the exponent. X plus 2 squared is not the same thing as x squared plus 4. I see this all the time. Please don't be that guy. Please don't do that. We'll talk about in later videos what that actually means, but just know it doesn't distribute like that. The final rule that we're going to talk about is what I call fraction exponents, but again, on Google, they're often referred to as rational exponents. This is when we have an exponent that is not a whole number. Instead, we represent it as a fraction. Here we have x to the m divided by n power. This is one of those links between different fields of mathematics. We are going between exponents and radicals. When we are converting this rational exponent into a radical notation, here's our radical here. The bottom number of our fraction becomes the index of our radical, while the base goes inside of the radical, and the top number of our fraction becomes the exponent for our base, all underneath the radical. As I said in later videos, we will go over each of these exponent rules in much more detail, but I hope that this gives you a good survey of some of the basic exponent rules so that maybe you can try some problems on your own. Once again, this has been DeVore, reporting from DeVore's room, and once again, just remember to be awesome.